So I would like to, we have a really special guest today, dear Selami Gürel, founding partner, president and CEO of Metal Yapı Engineering and Construction. And I would like to introduce Mr. Gürel to you briefly. Mr. Gürel was graduated from Middle East Technical University, Mechanical Engineering Department as Master of Science Engineer, and 46 years ago with the 3.89 GPA. And the Mr. Gürel have undertaken quite significant roles in his professional life as site manager, co-founder, general manager, vice executive officer, and now he's carrying on his career in his company. Gürel's professional interests are mainly steel construction, structural facades, tensile structures, steel bridges, and designing special bespoke industrial equipment. Mr. Gürel, welcome again. Thank you very much for being here today.
My name is Selami. I firstly introduce myself as I don't know if you've heard of the Turkish Constructional Steelwork Association. TUKSA it's called. You can check it on the internet. TUKSA is the association of factories who are dealing with steel structure, the engineers, also the university teachers, professors regarding steel structure. I'm founding partner. I don't know, Esra, do you remember? I think passed away at that time in Istanbul Technical University. There was Professor Tevfik Seno Arda. Maybe you have seen some of his books.
Yes,
he was
He
was for steel structure. Together with him, we have established this organization as a member of European ECCS years ago. Now, it's a good organization. Metal Yapı Engineering and Construction, if you check in internet, you will see what I am doing. Now, I'm a mechanical engineer. I'm dealing with construction projects, but you are architects. So let me try to influence you. What can I do for you in the future? Or what you can do together, what we can do together. Some of my friends, some of their work. Jürgen Meyer. Jürgen Meyer is from Berlin. Do you know this project? Metropol Parasol. Do you see my screen?
Yes, your screen is seen right now. Yeah.
Okay. This is in Spain. Only vertical elements in X and Y direction. Wooden frame structure. We have worked, he did also the south border gate between Turkey and Georgia on Black Sea. Sarp sınır kapısı. That is his project for Georgia. It is a 30-meter high, 30-meter high steel sculpture. I don't know what it means, but you are architects, you can name it better than I do. But we did it. This is his image or model. This is what I fabricated and installed over there. If you are planning to do such a thing, you need a good engineer next to you that you can rely on, that he can teach you how to do it. I mean, when you look at the dimensions, you cannot carry it from Turkey factory as ready-made. You cannot ship there. So what we did, we have established a fabrication yard just on the coast. It is on a jetty on Black Sea, very near to Batumi, north of Batumi. Fabricated, lifted, installed, bolted, welded, painted. This is another project. I mean, I am trying, I don't know if I can get some feedback from you, but let me first show you, for me, what was interesting. Then we will discuss with you what is interesting to you. This such a job is interesting for me because it's not a common column beam roof, floors, ceramic, nothing. Here, it's everything is special. Similarly, Mr. Fuchsas, Massimiliano Fuchsas from Italy, he has designed a shopping mall, Bori Mall, in Bratislava, Slovak. It is a new development. That is a shopping mall. And here in the center is a garden, inner garden, inside the shopping mall. As you see, it is a roof and a facade combined. And nothing is vertical, nothing is horizontal. All beams, members, all glass dimensions are unique. Nothing is repeated. This is on purpose. When I asked Massimiliano, why don't we make them vertical? He said, no, never in my life. He likes, and this is how, that was how he designed. This is what I built. Do you see my screen?
Yes.
Do
Yes,
you
this
like
is
it? Do you like it?
a really quite beautiful grid shell. It's also
Yeah,
facade, and as you can see on the roof.
yeah. This has three functions. First of all, it's a primary structure. I'm talking about my steel here. My steel structure is a primary load-bearing steel structure. Secondly, it is an internal decoration element. There's nothing more, just my structure. I hate when architect covers my structure because I do it so beautiful. You will see it now in all the details. You cannot do it with any plastering, with gypsum. Nothing can replace my structure. This system in this grid shell, those bars are called members, and this is called nodes. Members are nodes, if possible, bolted together. That was our contract, initial contract. But one day, Mr. Fuchs has said, Selami, I don't like those sharp edges here. Can we get rid of them? I said, how do you want? Send it to me. So he machined all those, and he said, I want such a note. And this is his original. That's his color, the Ferrari color, I think it's called. Then we started by using SolidWorks software. This is something you must learn how to use, architects, dear architects. If you are only with AutoCAD, never don't leave this job. You cannot do, you cannot live, you cannot survive. You need to go with better softwares. I'll show you at the very end of my presentation how today's architects are working. Since I am a mechanical engineer, I know the milling machines. I know how this SolidWorks, we make the design on computer and just give the order to the machine. The machine, milling machine, it's called milling machine. We finish the node, remember, all precisely. Here we go and bolt it together through this opening. And then we close those openings, we install on scaffolding one by one, and then place, make the fire protection painting, make the aluminum gasket system installed on the steel, and then put the glazing, put the solid panels, and finish the structure. I was telling you, this is an outer envelope in the meantime. This system has three functions: main structure, internal decoration, and external wall, just with one shot. I would like to show you this detail. This is my product. It is fully machined. We just bolt them and make painting repairs. Maybe we apply the final painting inside. But there is no other alternative in the world to be able to reach such an organic connection. This is why this is under my patent, which is called organic node worldwide. Another famous project, Foster and Partners from London for Kazakhstan. Foster for President Nazarbayev wanted to design a library. This is called First National Library of Kazakhstan. 90-meter diameter. No columns, no beams, nothing. Just roof. Like an eggshell, like a skin, or what, I don't know those words, but just members and nodes. 90-meter diameter. The important is this height of the steel beam is just 30 centimeters, 300 millimeters, 300 millimeters high. Steel members in 90 meters diameter. If you speak with any structural engineer around you, just ask him, what should be the height of the steel roof members if the span is 90 meters? They will tell you 9 meters or 5 meter minimum. We made it with 0.3 meters. This is the structural, that's a motion, movement from the structural model. It looks like a balloon, you know, it's very filigree Greek shell. Of course, it is exaggerated movement, but when you step on the roof, you feel that there is a kind of metro passing under you. You feel some movement. The important is in architectural structures, the important is the beauty of the joint. This is not a pipeline that you see the bolts. This is why in my design, we hide the bolts through the openings on the upper surface, where later it will be closed with glass glazing. Again, node members, all are machined precisely because any dimensional failure can lead a collapse of the structure. You see here, the members are shipped to Kazakhstan and then assembled on the ground in modules, lifted up. Those yellow ones are temporary supports, about 500 tons, by the way, the temporary supports, because until the roof is closed 100%, you cannot release the supports underneath those supports. See those yellow structure underneath. These are all calculated structurally. We need to calculate them. We need to see if it is strong enough until everything is. Then we release the support, and then the roof stands on its own structure. Then we start again with aluminum, with glass installation. Installing glass is also on some steps, you know. You cannot do everything. You cannot start from the top. You should start from bottom on a calculated manner. Everything should be calculated. Otherwise, since it's very thin structure, you can face difficulties. Well, this is one of my favorite projects and one of the most difficult in my life. When my guys in Kazakhstan, they were releasing the yellow structure, temporary structure underneath, I was waiting for their phone call. Is everything okay? There were two alternatives. The roof stands or the roof collapses. You cannot, there's no other alternative in such structures. The original structural design initially was made by Bureau Happold. Bureau Happold is the right hand of Norman Foster. As I told you, every successful special architect needs a special engineer just next to him to call him, Mike, I'm planning to design something like this. What could be the minimum size of the member? That's the way how it starts. You need to rely yourself. If you are so special architect, you need to have good contacts with good engineers. Otherwise, you can't do by yourself. Or you will finish both structural engineering and architecture, like Santiago Calatrava, for example. Mr. Calatrava is both of them. So here we are with Santiago. This is Gare de Lyon in Belgium, one of his latest. Oh, did I write Switzerland? He's from Switzerland, but that's a railway station existing. You know what do you call it? Peygamber böceği mi? Yusufçuk böceği mi? Öyle bir şey vardır. Ne derler adına onun İngilizce? Böyle kelebek gibi. Anyhow, the railway station, I mean, Mr. Calatrava's success is in the repeated structures. You know? He draws very difficult structures, but he uses it many times. If I can use the same structure 100 times, then it becomes cheap. But if I use every structure once and change every time, then it becomes expensive. The challenge, why this job came to me, let me tell you. The client, GAR, the Euroguard, they said, while you are constructing this station, you will not stop my railway operations. That means while we were working above, they will be running the wagons underneath. So how we did it? We have made some temporary structures underneath, finished everything on one side, welded, painted, and slide over those supports. This is called incremental launching method. You see, here we are first pull 3,000 ton sliding. Check the wagons running underneath while we are sliding. Launching, incremental launching method in the center of Europe by a small Turkish company. We're not so small, but
not a small, yeah.
All right. So Mr. Calatrava came to our office twice during that time. We are very happy to meet with him, work for him. Okay, let us step. There is another Foster project. Maybe some of you know this. This is world's biggest tent in Kazakhstan. It's very, very unique structure. And in my eyes, that structure has a very big logic. President Nazarbayev, do you see the car park all around, the cars parking around? This is a 250-meter diameter shopping center underneath. 5, 6 floors, car parks, basement, and on the top, cinema, some small Disneyland, swimming pool. If you're, I don't know if you've been to Kazakhstan, it is minus 40 degrees. Now I think it is today -5 something. We are in October. Now, if you are in -5 in Kazakhstan and money and want to have some walk, you cannot walk on the street. It is very similar to summertime in Dubai. You cannot walk in summertime because of the high temperature and high humidity. In Kazakhstan, you cannot do it in wintertime. This is why you need a microclimate, an environment that you go in. The simplest way is to use plastic sheeting as a cover. But plastic should not stop the heat. I mean, we need something with a heat transfer value. So this is why Foster decided to use inflated plastic cushion. This is called inflated cushion by using ETFE, ethyl tetrafluoride. Just a central post on the center, steel ropes, and cushions. Finished. This was the most economical solution because tensile elements can be very economical if you know how to use them. Central post, of course, is very critical because here in this case, on the main leg, we have almost 10,000 tons of compressive force coming from cables under wind load, etc., not only the dead weight. But it's like a sailing boat. This is the top floor that people like a small theme park, Disneyland. The method of construction was very special. I mean, if you look at this tripod, this height is 100 meters. That structure is 2,000 tons. That triangular truss is about 5 meter by 5 meter triangle. Very big dimensions. You cannot fabricate and put it there by very heavy cranes. This is why I have developed a special system, again, by using hydraulic jacks. Heavy lifting, this is called. If you text in internet, you will read VSL or Fresina. Those are the companies who use those machines. I rent from them. Here, the tripod is fully completed on the ground level. And then I decided to use a temporary power here, tie back, and then hold from this point and pull. Simple pulling up. Pull. Do you hear, Esa?
I just give some explanation about if you have some questions, they can ask at the end of the seminar.
No, my question, sorry. Do you hear the National
No,
Geographic?
No, I didn't hear. Sorry about that.
We can only see the video, but cannot hear, unfortunately.
Yes.
Oh, that's bad. Well, anyhow, this is a video about me. You should hear it.
Because actually, here, I'm seeing there is a volume bar over here in the right side. Maybe you can just roll up. We can hear.
The Selami Gürel.
Yes, you can hear right now.
The experts talk of impossible. Sembel calls in Gürel. The pressure is just the time. Everybody wants his building on time. But in this weather conditions, it's very, very difficult. Even in the good year, winter in central Kazakhstan is bone chilling. And this winter has been unusually extreme. When the wind starts, you feel minus 55. It's very so cold that for many workers it's a fine line between life and a freezing death. I remember one day they said someone is frozen up there. So the team went up and took him down. Such things happen. The frozen workers survived. But Selami faces a far bigger problem than the kiln. And that's Kazakhstan's president, Nazarbayev. The president personally commissioned the building. He's tired of waiting for it and has now demanded that it must be finished in time for his birthday. Just 18 weeks' time. And in Kazakhstan, when the president shouts, everybody jumps. The next stage is to build and erect the 10th pole, a 2,000-ton steel structure that will rise 150 meters into the air. Unfortunately, it seems that no one can agree how they're going to do it. Time to bring in the troubleshooter, Selami Gürel. Building it without any further delays was a challenge that Selami was determined to solve. Being an engineer of 58 years old, from the great idea that he wanted to do everything on the ground, assemble everything, and then wanted to have nothing available. Imagine you should rent eight tunnels. It will be some very high-tech winches, while Selami's team will build a 60-meter tall tower, on top of which he will put his specialist winches, known as strand jacks. The jacks will pull up the tripod on its hinges, with the third leg sliding down the track into its final position. It's never been done before. No one knows if it will work. The cables are into the air. The secret weapon was screwdriver. So there's always that danger that some there were thousands of the concrete rhythm.
Well, I think that's enough for this project. But method is important, how to do it. You cannot weld 2,000 ton up in 100 meter at minus 40 degrees temperature. You must do everything on the ground with covering with some tent, heating the steel, heating the welders. Anyhow, that's another fantastic project that Melike Altınışık did. The new tower of television tower in Küçük Çamlıca in Istanbul. Do you hear me?
Yes, yes, I can hear you. But for the
We
previous
can stop.
project, I'm so
Yeah.
sorry, Mr. Gürel. For the previous project, this is really exciting that to see you're also conducting a construction process design too, and I think it's really quite important because even if it is a safe structure, if you can't install that, it will not be existed. So you are also designing some equipments just for this construction. I think this is the most important part of.
Yeah, this is called, let me tell you one thing.
Yeah.
This is called method of statement.
Yeah.
MOS we call it. Shortly, it's MOS. Method of statement means a designer, while designing something, should explain how to build it. The method. But unfortunately, in this project, neither Foster and Partners nor Bureau Happold, they didn't define any methodology, which was a big mistake. Then I dictated the methodology, Thanks God, Sembol said, Selami, that's your baby, do it. So I took it. The method, how to lift it, is only my pure thinking, This was my first hand sketch, I said, let's do it that way, and we did it. This is related with some living with the project,
Yeah.
I don't know when you sleep, what are your dreams? But my dreams are my projects. I have a height anxiety. I cannot go very high by myself, by ladders in construction site and so on. So what I do, I'm always very afraid that an engineer will call me, Selami Bey, we have a problem, come up there. So in order not to live it, I dream every step of it, you know, in my mind. I dream everything, how to do it. Now he's putting the bolt, tightening the bolt, welding, lifting. How can he lower it down afterwards? This is very important, you know. It is the secret of our success in fact. Because engineering, you know, engineering is very expensive in Europe, not in Turkey, by the way. Engineering and architecture is not expensive in Turkey, but over there it is expensive. If you ask a company to make also the construction engineering, this is called, not the structural engineering, construction method engineering,
Yeah.
then it is an extra money. The way you will see now in Melike's tower project, up to here is 200-meter concrete core. Above is 160 meters of steel antenna. And the outside is GRC covered, glazed, and GRC solid panel floors, as you see here. The antenna is 1,200 tons, 160 meters. The method, how I lifted it. After the antenna lifted up, we must connect it with the concrete. This drawing, this AutoCAD drawing, is my own sketch. I did it in one night. I asked my guys, what is the dimension of the core? That's the core. So if we make an opening here, I can put the antenna in, lift up, put the second one in, continue lifting, welding. So I built everything inside the concrete core. Then I hold the whole antenna and lift up like a telescope system. So this is how we design. That's also from my design. I put rails here and the antenna. Here in the original design, there was a staircase. I said to Melike, don't put the staircase now. We will build it later. Let us first finish the antenna, then we lift. These are the hydraulic jacks lifting, 200 ton each. We have 8 of them. This is the temporary structure for lifting. See, all that structure is temporary here. This is the internal core. That's a temporary opening on the concrete core. This is my design, a simple sliding roller carriage, let us say, pushing by hydraulically step by step, going in. The carriage, let me go a bit fast. Top lifting piece. There was a video here, I think. See, the pieces are, the parts are finished outside, slide in, and then welded inside, lifting one by one. Lifting, welding, the other piece. See, I had some guys who love to live up there, They can sleep over there. I can't imagine. How come they go? So after we have finished the antenna, we started building the external part. the floors, let us say. Can you see those yellow pieces? These are the hydraulic strand jack, we call it, hydraulic strand lifting unit. This is the cable coming down. We finished this block about 1,000 ton and jack up to 100, 200 meter. And then weld all the beams to the embedded anchors inside. You see, it's going up now. The block is going up as a whole. Then we start with the second. See, this is the first block, 4 floor. The second block, another 4 floor. Third one, fourth one. Can you imagine you are installing this GRC up in 200 meters? By the way, in this construction, one of my workers fell down and died, unfortunately. If we were not using such a system, I don't know how many people was lost.
So this is somehow some precast system. So you're installing all these floors in the ground, and afterwards you're uplifted all this structure and embedded into the RC concrete core, right?
Right. This is, I think they put some lighting now. I don't know the final case, but my work is finished here after lifting all those heavy parts. But that part is just the skin, nothing special, no steel. So that skin part they have finished, the main contractor finished. But I believe this is a success of Turkish architecture. Melike Altınışık worked with Zaha Hadid in London in the past. She is very special. I mean, if you can meet with her, if you can work with her, you will enjoy it terribly. But she's highly software-minded, you know. You need some special software. Similarly, Nita Architects, I think they are from Antalya, the Expo Tower in Antalya. This is another story we did. Still, the main contractor does not exist and has a debt of 2 million euro to our company. Still, we are waiting to get our money. This was in 2016, 4 years ago. Let's go fast just to show you how we are lifting. Hydraulic jack. Again. Guiding roller. These are all temporary. Skylight. We finished everything on the ground.
Kaldırıyoruz. Herkese bakmalar. Birinci kat, ikinci kat hafifçe. Üçüncü kat hafifçe. Nefes kalkmış oldu. Ortalama 729 sol. Yüksek, buraya yüksek. 128 hem aynı. 3 numarayla 4 numaralı bir soru takip et abi. Var mı sana geldi? Şimdi söyle.
Well, that's another one. Kazakh Pavilion. I don't know if you know this company, Adrian Smith Gordon Gill from America, ASGG. They are also very special. SOM architects, you know, some architects. They were senior architects in SOM before. Now they're their own company. That's an expo center. Expo, I think it was 2018. Anyhow, here is the Kazakh pavilion, 80-meter diameter glass glazed. I don't know how an architect starts designing an expo center, but here I understand that. Adrian Smith, Gordon Gill, they said, let's put Kazakhstan into the center and put some other pavilions and given to the other countries. And on the external perimeter, they put some hotels, etc. And the way they design it is always with grid shells and everything, like this. Today's architecture. What I did, I made the main primary steel structure, including design of it. This is a really difficult steel structure. As you see, everything is curved with radius, expensive. I don't know if you can see the man here, how small is the man? That's the beam on the second floor. Expo, I don't remember, 12,000 tons. For me, when I say steel structure, it is tons. I have another one now, a recent project in Abu Dhabi, Sheikh Zayed National Museum, another Foster project. We have 15 minutes. Yes, Esra?
Sorry, yes, approximately, and maybe some students may have some questions to you after your seminar will be end.
Yeah, okay. I have some. This is a terribly difficult project. Foster and Partners made the most expensive museum in the world. If you ask me, frankly speaking, I don't support such money expenditures while half of the world is hungry. Anyhow, this is United Arab Emirates. I think you have some guys from Emirates. Do you have some students from UAE or which countries you have? Anyhow, we'll talk later. Here, my mission is not very big. I am making the gates here. You see this entrance gate on the left side and that entrance gate on the right side. And those pots, they call it pots. I don't know what it means, but this is a terribly difficult double curve structure here. This is glass. This is glass. These are all stainless steel wings, they call it. And that is our fabrication, all double curve. And this is a, for example, 10-meter high steel gate, opening and closing, 6 pieces. Since I'm a mechanical engineer, I designed those opening and closing mechanism. Anyhow, up to now, I have shown you what I did. But from now on, I will show you what I advise you to do. Modular buildings, off-site construction. If I was in your age, I would start spending time and money on this subject. I'll show you a very nice project in London, Croydon House. Assume that you are in the middle of London. There is no construction yard, only the building area. Here, maybe you haven't noticed. Just this part. You cannot put even a truck inside. Just a truck can come. Nighttime, you lift it up. Right side is full, left is full. Each side is full. How can you build such a high tower in the middle of London, where the land is expensive, where the labor is very, very, very expensive? How they did? This company, Vision Modular, take a note of this name. Vision Modular is one of the best. They built 44-story high modular building. What is modular building? Modular building is fabricated in a factory, fully finished. I'm not joking. It's fully finished and then put in place by cranes. Of course, the concrete core here is made by slip form or whatever. But those blocks, rooms, or the houses around are all modular fabricated in a factory and then lifted, chick, chick, chick, chick. 95% factory finished. You cannot do this in Turkey because in Turkey, labor is very cheap. Man is very cheap. They can fall and die. Nobody cares. Right? You remember what happened in Zincirlikuyu? 10 people died. What happened? Nothing. They can block the traffic. Nobody cares. But it's not in London. You can't do it. You cannot put a hammer after 6 o'clock. You cannot make any welding at site. So, for example, this is in New York, the stack. That's another very special modular building. You see, all house comes within a package, and you just put it on top of each other. That's an apartment in Germany that we have designed, not me, ARNC architects from Istanbul. Berk, very clever guy, 3-story for a German suburb. You see, the modular building, you need to know how you can design by simple rectangles, how you can make a 2-bedroom, 1-bedroom, I mean, sufficient living space. But the logic is always rectangles, rectangular plans. So that is our 3D model. That is the architect's impression, what he wants to see inside. All finished. That is, then I start to design my steel structure, bolted in order, I mean, that cubicle, or what do you call it, volumetric block is fabricated, covered with fire-rated boards, finished everything inside, finished the facade, ready to be shipped, you see? You can lift it, pack it, and send to London or Germany. This is, Esra, I'm very serious. This is for the future. If you are working for United States, for UK, for Germany and France, you can sell this system. That is the future for expensive land and expensive labor countries. Not for Turkey, not for Africa, I repeat. This is expensive. That is after. Can you see? Here is the joint between 2 blocks when they come together. I think we have another one there. Bathroom pots. For the tower building, we make ready-made bathroom. Bathroom is the most difficult part of a house. Why? You need ceramic, you need electric, you need piping, sewage, hot water, radiator, bath, tub, closet, reservoir. Can you imagine? Nobody allows you to do it in London in a town. They buy it like this and put it on. On every floor, when they build, they put it on. That's another job for you. We need good architects to design economical, good products. What was it called? Bathroom pots. We have also kitchen pots, You can sell the whole kitchen, including Beko, those furnaces, oven, or what you call it, refrigerator. I remember when the British inspector came to our factory, I have thrown out 3 prototypes because the distance between 2 ceramic was not parallel. 3 millimeter, he said. He was shouting at my engineer. Can I see your 3 meter? 3 millimeter, he said. Show me your 3 millimeter. My 3mm is this much. Huh? Why the hell is yours 5mm? Or on this side 2mm, other side 4mm. It should be just 3mm. I don't know. I mean, I never do it myself if I am there. Another special job for London is the balcony, ready-made balcony. The building is finished, and then chick, chick, chick, we put the balconies from outside. These are from our balcony factory in Istanbul. We finish everything, put on a trailer and send to London. That's in London. They lift it and install it. This is not a good money, not very profitable. I don't advise you. Well, anyhow, we are doing balconies in London now, shipping from Turkey. Now, Esra, I added this. It was not in my presentation, but it's very new, and I want you all to know about this.
Thank you very much.
Take a note, monocoque. Monocoque is a very special word, monocoque. Monocoque, I'll tell you what it means. This is a race car in Formula One, maybe Ferrari, I don't know, whatever it is. A race car, you see the curves of the race car, like a smooth organic shape. That was made before. There was a strong inner structure, and there was very thin metallic or plastic external skin structure. Now, it is not the case. Now, the external skin itself is the main structure. There's nothing more. So this is called monocoque technology, like a monolith. It's in fact skin with stiffeners inside, load-bearing stiffeners. When you go in a ferry boat with your car, let's say to Mudanya, yeah? When you go into a ferry boat is made of aluminum. And as you see, the external skin has very nice curves. And internal, there are stiffeners. This is called monocoque technology. There's nothing else. Before, there was a heavy steel structure, and then there were some external skin. There was an internal decoration. Now, I'll show you Frank Gehry's Colorado Pavilion. You know Mr. Gehry, I believe. Frank Gehry, that is his design. He just, I heard it, you know, he just scratched it. What do you call it in English? I don't know. He killed a paper and just throw there and said, Esra, I want this. So that's it.
Yeah.
Take a note of this architecture company name. CIG Architecture is one of the number one, not one of the, but is the number one 3D architectural manufacturer of metals. This is made of metal, stainless steel. How do you see the piece?
Yeah.
It is, let's say, 6mm thick stainless steel formed. But I want to, steps of the design, creation of 3D model. First of all, you should learn how do you get from this architect's wish, you must convert it into a readable 3D model, right? The best system today is Rhino, but Gehry is using another system, which is called
I guess Katya or something.
similar, Katya-based. It's Katya-based. Project PD or DP, digital project, sorry, DP, digital project. I think it's very expensive, but you can find the cracks. Try to learn digital project. It is for the future. Not only Rhino. Rhino is unavoidable. rhino and grasshopper. If you don't know it, never come to my office. If you want to work in such environment, read it here. The 3D architectural design in 3DM. I think 3DM is Rhino or Revit. I don't know what is 3DM.
Yeah, this is the abbreviation of Rhino documents, I guess.
Okay, this is Rhino. And then from Rhino, controlled by Grasshopper. Grasshopper is also a must today, ladies and gentlemen. Rhino and Grasshopper. If you know this, you can work in this company easily. Of course, with your fluent English and nice diction, accent. So this is by chance, Esra. I get to know this company just 2 days ago. You know?
Really? Oh.
Yeah. So I wanted to share with you because I have a very special project currently in Saudi Arabia. But unfortunately, Saudi Arabian guys are putting some embargo and sanctions. Feras, are you Saudi?
Actually, I came from Saudi Arabia.
Where are you from originally?
Syrian. I'm a Syrian, actually.
Oh, lovely. You are one of us.
Yeah.
So what do you mean you came from Saudi?
Actually, yeah, I have been in Saudi Arabia for a long time.
So your
since I born.
parents are living there, right?
Yeah.
So this is that small machine, Esra, without mechanical engineers, you cannot live.
Yeah.
You need good engineers, you know?
Yes.
By pressing, you prepare. Similarly, like metal, we have concrete products, double curve. You know, double curve is the future of anything. I highly advise you to check this company's webpage, CIG-architecture.com. CIG Architecture. They are very, very, very special. I mean, after me. UHPC, ultra high performance concrete, looks like GRC. Can you see this geometry? How can you do this? Just put yourself, I mean, assume that you are not the architect. You are the one who will build it. Assume that Zaha Hadid wanted something like this, and we together will build it. How you can do it with concrete? Tell me.
Is there any ideas? I'm sorry.
Sorry? Yes, carry on. What did you say?
Is there any idea how we can build like this, guys?
Layering technique, maybe.
Sorry?
Layering technique.
No, the technology, I'll show you the technology. First of all, you should study what is ultra high performance concrete, UHPC. UHPC is a concrete which is as strong as steel. So it is not 100 millimeter thick. It is also very thin. I mean, that structure is only 25 millimeter thick. Of course, there is some reinforcement inside. You can see here the normal reinforced concrete, pre-stressed concrete, steel I-beam, and ductile. Ductile is from Lafarge. Lafarge is the trademark of Lafarge. Ductile is Lafarge product as UHPC. Can you see the geometry? The double curve is the natural shape in the nature, you know, a wood, a leaf, but a bird. Those are able to carry by themselves like a monocoque system. So that's for Melbourne, for instance. All those are concrete products, but very thin and very light, but very strong. Here in France, the roof of a station, there is no steel, nothing, just the roof piece. You know, these are made of concrete and finished, painted, that's it. No decoration, No external cladding, no internal steel structure, nothing. That's also the future as a high-tech architecture. Here, Qatar, for example, Al Rayyan, that
Can I
is
ask a question?
also,
I'm sorry, I am interrupting, but you mean that there is some reinforcements inside of the concrete? You mean the fiber reinforcements, or we are
yes,
talking?
yes,
Yeah.
yes.
Okay.
Yeah. It is, when I say GRC, it is glass fiber reinforced concrete.
Okay.
Sometimes it's called GFRC.
Yeah.
But now we are talking a concrete level higher than that,
Mm-hmm.
which is ultra high performance concrete, again with some fiber reinforcement inside. You're not supposed to calculate it, you know. You should know that if you make something a double curve,
Mm-hmm.
I mean, a thin shell able to stand itself,
Yeah. Due to the
it
form.
becomes that it becomes the most economical solution
Yeah.
at the end, and it becomes the most, let us say, long-living solution. You just make some painting, maybe. All right, Al Rayyan. For example, I think this is in Dubai. Some of you maybe know Toyota Plaza Housing or something. You see, this wall is not only a decoration; it's an external wall, fully finished. And this is the machine to make the form. Again, you need mechanism, you need machinery, but very cheap. You make some wooden layers, glue them, and then mill it. This becomes the formwork for your product. Then you just spray the UHPC that you buy from Lafarge. Now, my expensive stuff is finished. My last 5 photos are regarding the very economical solution for Africa, Mali and Mozambique. I had a chance to work with architect Diabedo Francis Kere. You should know him also. He's a very special guy from Burkina Faso, living in Berlin. He finds some financing worldwide from Agahan Foundation or from others. And then he tries to develop some projects for Africa by using their local material. This is a very simple job I made for Mali, Bamako. This is National Park of Mali. He first was teaching to the Africans how to make the bricks by themselves. What I did was only that steel roof structure because, you know, the African rain, when the rain comes, you are finished. So you must have a good, strong roof structure. I mean, I just wanted to show you very economical, very cheap. But when I designed it by myself because when I give it to one of my engineers, they just prepare it as a welded structure. But how can you ship a welded structure from Istanbul to Bamako? Or this is, for example, for Tete in Mozambique. You have to find some boltable, you know, disassembled, no welding. I mean, pieces must be easily packable inside. You see, these are just simple pipes, all very nicely fabricated, no distortion, nothing. Well, I think I am finished.
Thank you very much for all this examples and the buildings, and it's really valuable for us that you shared your experiences experiences of the for the 6 years. So thanks a lot.
Very nice. I wish you good luck. I mean, your future is not bright. I am very sorry to say that. Population is growing. 100 universities opening. There are many students coming. You need to have something different in your personal asset. What is it? Rhino, grasshopper, English, French, good diction of speaking. I am sure that you all understood my English, did you?
Yeah, for sure.
You must.
Yes, we understood.
Because I speak very clearly. I care for my speaking so that every stupid one can understand what I'm saying. I don't mean you, but it comes from my factory life. You know? I am talking to my worker. How can a worker understand if I explain him in a high level discussion? I must be very clear and open. For that, you must spend time to your diction and to your accent, to your language. By the way, I speak very well Russian language. I speak very good Turkish and very good German. You need to do it. I mean, you are free now. You're not going in traffic. Why don't you learn more? I don't know what will you do with it if you can't go to Russia. I told you you
Yeah,
have a
we hope.
difficult. Yeah, I hope you will be
Yeah.
successful. I'm leaving now, tired.
Okay.
Bye-bye. Thank you.
Thank you very
Bye.
much.
Bye-bye.
Thank you
Bye-bye.
so
So
much
much.
again. Hope to
Thank
see
you.
you.
Bye. Bye-bye. Bye.